Hello guys, this is Sar Krishna. I'm, um, I'm here to have a seminar which is on problem solving with C language. So essentially, we are going to take a problem statement, analyze it, and write code on it, and finally solve the problem. So let's start the seminar. About me, I'm a student currently pursuing a data science bachelor's degree at IARE. So what are our objectives over here? It is first we will introduce to ourselves with C, next decision control in C, looping statements in C, the program development steps, and the output. So first we will cover the basis of basic things that we present in the code so that to have a prior knowledge of what we are actually doing, then we will follow the well-established program development steps one by one to build the code and logic properly to get minimal errors and a smoother execution. So let's start with introduction. C is a general-purpose programming language created by Dennis Ritchie at the Bell Laboratory in 1972. It is a very popular language despite being old. C is strongly associated with Unix and it was developed to write the Unix operating system. If you know, Unix was predecessor of Linux. The main difference between C and C++ is that C++ supports classes and objects while C does not. So we can say that C++ is an upgraded and updated version of C, but C has its own prominence and applications. So let's move on to decision control statements in C. Now we will start with a simple if statement. So as you can see in the flowchart, there will be a condition. If the condition is satisfied, then uh, then it will evaluate it be as true, and the code which is corresponding to the truth block will get executed. If it corresponds to false, then the code corresponding to the false box will get executed. And at the bottom there is a small example which is basically on checking your eligibility on voting. So here you will one will take your age as an input and print out a return whether you are eligible or not to vote. That is, simply write an expression where if your age is less than 18, you are not eligible. If your age is greater than or equal to 18, you are eligible to vote. This is a simple if statement. Let's move on to something more complex, that is if else statement. Suppose if we know that if the expression is evaluated to be true, then a certain code block will be executed. What happens if it is evaluated to false? Then it has to execute a corresponding code block. For that we have else. So else is like when if doesn't work, else code works. So here also we are taking an example whether to check a number is even or odd. So let us say assume under if statement we have written if a number is divisible by 2, then it should be printed as even. But if the if expression is not evaluated as true, then by using else we can print that the number is odd. That is the combination of if else statement. Next, we have nested if-else statements. Suppose there might arise a condition or scenario where we need to use multiple if-else statements, and there may be some scenarios where you need to use multiple if-else inside one if or an else. Such type of scenarios are considered to be nested if-else statements, and these are generally used in some complicated or complex decision-making programs. We have the last decision control statement, that is if else if statement. So assume we know that we if suppose you need to evaluate a code or evaluate an input based on multiple expressions, then one can actually use if and else if. So else if is nothing but an extension to if, that is if expression is not being evaluated as true, then the second option would be the else if, then another else if, so on until you give else. So else is like a stopping point for these decision structures. By this slide, we have completed and we'll have a brief knowledge about decision control statements and C. Now let's move on to looping statements and C. So first it is while loop. Now while loop is an entry controlled loop. Entry control loop, and while loop has an expression, and the loop continues until the looping expression returns false. So the looping expression can be made to return false at a certain moment of the loop, or a certain number of loop, by using decision control statements, that is while loop. Next we have do while loop. Now do while loop is nothing but a breakdown version of while loop, where we actually write the programmable code first before writing the looping expression. So that is do while, a fancy way of writing a while loop. Next we have the legend, that is for loop, which everyone uses mostly. It's my personal favorite. And here also it is simple thing. You give a evaluating expression, sorry, looping expression. It will loop until the expression returns false. But the expressions in all these looping statements must be given in braces, that is in parentheses. By this we have completed our looping statements. So now we have a brief knowledge over what are looping statements and how we can execute them. Next comes program development steps in C. See, C is a programming language, and once a great man has said to me, coding essentially is defining your intuition to solve a particular problem. That is, you have the imagination to solve a problem in a certain way. Code or programming essentially helps you to actually implement your intuition in real life and solve the problem. Now, for this, it will not like be that you have the idea, you just write some lines and the program got executed. You have to follow a certain procedure in order to have minimal friction while developing the program and get maximum results. For that very reason, a well-designed program development steps were made. So by following these steps, we will be able to create a much greater program, and which actually returns great outputs without causing us much of a headache. So let's start with statement of problem. Working with the existing system and using proper questionnaire, the problem should be explained clearly. What inputs are available and outputs are required, what is needed for creating a workable solution should be understood clearly. In the field of computer science and engineering, it is very important that one has to concentrate on defining the problem rather defining the solution or working on the solution. If you are able to practically define the problem, then making a solution for it will become much easier than you do it in reverse order. So here the problem statement that is given to us is, you are batting at the pitch and all eyes are on you. Well, I'm famous, the best player in all of IPL. That's me. Even though I do not watch IPL, I am the best player in IPL. So let's assume the opposing team will relentlessly bowl at you an infinite number of balls. Thank God I have the god level stamina. Thor, I am better than you. You notice that you only ever score a boundary on the mth ball. Why not make it every ball? If n mod m question mark n by 2, now the question mark symbolizes nothing here. So I just assumed it represents less than or equal to, where equal to sign is over n by 2, where n is my lucky number, of a lucky number which is printed on my t-shirt. So obviously it would be 7, which is my lucky number. Now you want to know how many boundaries will you hit in total. Okay, formally you are given a positive integer n, and you need to find the number of positive integers m such that n mod m less than or equal to n by 2. Oh, pretty good problem. So here the evaluating expression that is mainly given to us is n mod m less than or equal to n by 2. And we have to read a positive integer, which is essentially my lucky number. Okay, that's good. So let's analyze the problem first. Analyze this. The methods of solution to solve the problem can be identified. We also judge which methods gives the best results among different methods of solution. So here analysis is nothing but choosing which approach is much efficient and less time consuming, less complex. By this one can actually save time and complexity while writing code or while developing the code. For example, we actually need a for loop, we actually need a looping statement and a decision control statement. As we have been informed, there are multiple looping statements and multiple decision control structures. So from that, we need to choose which satisfies our need the best. And for that reason, analysis is very important. So let's move on to the designing phase. Here is all fun starts. Take a so I have read. Wait a second. I just want. Yes. Yeah. So in designing, we actually create an algorithm and a flowchart. All right. So the algorithm that I written for this specific problem is take an integer as input, assign this integer as player's lucky number. Infinite number of balls are thrown to the batsman, but infinite number cannot be generated by Python, but actually it is C. So let's assume only 100 balls were thrown. So the loop which I was talking about should only iterate for 100 times. Now make a for loop, my personal favorite, with m value starting from 1 to 100. So here m signifies the number of balls thrown. As the number of ball throws cannot start with 0, it should start with 1. That's why it will start with 1. Now write a if statement to evaluate given expression n mod m less than or equal to n by 2. If given expression is satisfied, add an instance to the counter. Finally, print the counter. That's it. A pretty basic thing. Now, this is very fascinating. It is a flowchart. So we will start from the left. So we read lucky number n, and m would be equal to 1. The evaluating expression for the for loop would be m less than 1 not 1. And if it's true, then the decision control statement will be executed, which essentially is our expression. If that is true, then increment occurs, the counter gets added and all that stuff. And finally, when the loop iteration completes, we'll print the counter and end the process. That is what is being asked in this question. So this is the flowchart. Next, implementation. Now this is very important. The algorithms and flowcharts developed in the previous steps are converted into actual programs in the higher level languages like C. So the first step in implementation is compilation. Translate the programs into machine code. This process is called compilation. Syntactic errors are found quickly at the time of compiling the program. These errors occur due to the usage of wrong syntaxes. For the statements example, x is equal to a into y plus b, there is a syntax error in the statement since each and every statement in C language ends with a semicolon. So syntax is very important. Execution. Now The next step is program execution. In this phase, we may encounter two types of errors: runtime errors. These errors occurs during the execution of the program and terminates the program abnormally. Logical errors. These errors occur due to incorrect usage of instruction in the program. These errors are neither detected during compilation or execution nor cause any stoppage to the program execution, but produce incorrect output. So finally, the code. What is the actual code? As you can see, this is the code. You can pause the video and go through the code. It's a pretty much simple code. I have taken an effort to even write comments at each and every step, so to make you understand why something is there and what it's actually doing. So let's summarize and end this seminar. Utilizing the program development steps, the program has been solved. If was found out, batsman will bat a boundary for every ball he hits. So the funny thing is, the expression that was given to us is able to count, is able to predict that for every ball we throw to the batsman, it will be a 4. It's funny, but it is what it is. So thanks for listening, guys. Um, have a great day.